Hi folks, this is the tutorial number 15, which is a continuation of tutorial 10, 11, 12, 13, and 14. And I want to propose the strategy number 5, which is going to be involved with using the tie connections and solve the simple structure analysis problem using the 3D Experiences FEA module, which is the Abacus program. Let me remind you that we started in tutorial 10 by looking at this problem. And I call that thing the obvious strategy because all I did was create a line AB and then BC and applied the load after meshing, applied the load at the midpoint of this section AB. Now there is an internal hinge here. So in tutorial 11 through 14, I used a variety of different connections and connectors to solve this problem. What I want to do now in the final episode of this problem is to have a tie and a tie connection, except that when you tie these, for this one, you have to release the degrees of freedom, rotational degrees of freedom, because this being a hinge means that the rotation here does not translate to the rotation there. Moment does not transfer. That's why I call this thing killing a fly with a cannon, because it all goes back to tutorial 10, which didn't involve any connections, except for, of course, the connector for the hinge. Now, it's a problem from Hebler Structure Analysis book, and the way I assess whether I've done things correctly or not, I look at the theoretical displacement at the hinge, which should be 4.58 inches downward approximately, and the verification of that in the last 3 slides of the presentation. Now, so here's essentially my strategy. We have 3 lines, and I'm not going to join these, obviously, and concentrated load here, and the hinge is over there. So I create a tie node between a tie option between these 2 points, vertices, and another tie option between these 2 vertices. However, when it comes to this, I basically release the degrees of freedom just associated with rotation. So you make sure that this is unchecked, okay? Now, the question becomes, can I do that thing with the when I select the support for these ties, I did point vertex to vertex, vertex to vertex, but in an earlier tutorial I said that if you do a line here and a line there, it's also going to work. So we're going to try to see whether we can do this thing. Instead of selecting the vertices, we can select the lines. Actually, we're going to do that kind of the end. Make sure you don't join anything here, because you want to have duplicate nodes. And make sure that when you mesh these lines separately, this box is unchecked, because this being checked, so depending on the tolerance that you put in there, these 2 nodes may collapse to one another. Maybe you don't want to do that. Here's the analytical solution using the principle of virtual work, and you get roughly 4.58 inches. Let's go do that. We start with the part file, because I'm not going to use the join option, so there's no reason to go generative shape design. Now, let me create 3 lines. So line number 1. Oh, I forgot to mention something, and that is for this particular tie, for tie connection, you don't need an access system or local coordinate system. So we're not going to create that. So anyway, point and direction. Let's make a point 0, 0, 0, direction y, and that's going to be 12 feet. Another line using the same method, starting at this point in the direction y, also 12 feet. And the last piece of the geometry is 15 feet. So this point, direction y, and 15. Okay, good. Let's create our material properties. So we go to tools, add a material. I'll call this thing to tutorial 15. This is steel. Okay, so we'll make it. It's right here. So we take this thing, put it up there, check the green check mark, and now we go and put our values. Structural, abacus multiphysics, mechanical, elasticity, elastic, 29,000 KSI. That's 20 zeros, 29,000 KSI, Poisson ratio 0.3. That doesn't come into the calculation. All right, so now we're going to go and do the meshing. So let's go ahead to structural model creation, empty FEA model, get the beam measure, mesh tab, beam measure, 1 foot long, so there's going to be 12 elements there. Let's do it again for this guy. Remember, make sure that this checkbox is off. Same thing. Again, 1 foot long elements, so get 15 of them over here. Now, for properties, we go to properties, let's create a profile. That's going to be circular. The radius is 2.486 inches, because that will give you 30 inch to the 4 as I, which is used in the analytical solution. Good. And now create a section, beam section. You can select all these three and then use the profile number 1, and then we say okay. Good. So the connections, we're going to create connection here, tie. Let's do this one first. The first one is going to be, I'll call this thing tie for concentrated load. That's where we apply the concentrated load, just so that you remember where it is. So for the first support, I'm going to hide this, select this point, and for the secondary, I'm going to go and select the end of the piece that I hit right there. All right, and notice that we want to tie rotational degrees of freedom here, because this is not a hinge, so this should be on. Okay, good. So let's do another one over there on this side. So another one, this one I'm going to call tie, but for the hinge. So I can select this end. For the second one, I go to the hiding and select that end of the middle line. And notice that here we don't want to tie them, because there's a hinge there. So we uncheck that, and then we say okay. Good. So that should do it. Let's go and apply our loads. So we go to the structural scenario creation, select the model, FEA model. Now, for procedure, use the static perturbation, because all you're trying to do is to solve a simple linear problem. And for boundary conditions, that end is clamped. This end is clamped, and this end is on a roller. So go fix displacement, select this endpoint. Move, select this endpoint, and it can move in the direction Y, because it's a roller, it moves in the direction Y, but it cannot rotate about Y and Z. So we say okay. For the load, so we go to load. Let's do the force first. at this first point, these are tied together. At this first point, meaning that we're going to select that vertex, and if it doesn't work, we're going to create a group for node and put a node in it and then apply it there. I think this should work. So -8. Yeah, and then a concentrated moment at this end. So we go to torque. So that point, negative 3000, 30,000 pound-foot. And we're going to run this thing. First of all, if it runs, then if it bumps out because this doesn't take the load at that vertex, then we're going to fix it. So anyway, so let's go ahead and simulate. Let's do first of all, a model check. That went through. Let's do a simulation check. I don't anticipate any problems here, but we'll find out. Yeah, it's a good idea to check these things, because if there's anything obvious that is wrong, then we can fix it before actually we go in and run it. So this is fine, and now we're going to run it, and the deflection better be 4.58, and we'll see. Now, when it comes to the question that I asked earlier, let's wait for this thing to finish. Okay, so look at the displacement. Is it 4.58? Displacement, 4.58. So that works. This strategy works. Remember, I asked the question here, is it true that in this tutorial, when it comes to selecting support for tie, either use the vertices or that I did, or can I use the lines? So that's what I'm going to do now. I already know, let me first go here. I already know that when I did this line to that line in an earlier tutorial and tied these, it worked. Okay. The question is really becoming these two lines. So let's go to uh, the connection for the hinge, which was this one. Double click. Let me get rid of these supports. Okay. So for the support, I select this line and that line, and uncheck. Do not tie these. Do not tie the rotational degrees of freedom. The question is, oops, wait a minute. Something is wrong here. Let me check that. Two entities. Let me get rid of this. Remove. Okay, so that is this. And for this, I want to select this line. Yep. That line, first support, this line, second support, and this is unchecked. Good. So the question is, when I run, does it run? And when I run, do I get the same value? Okay, so let's first of all check the model. No problem there. And run it. Do we get 4.58? Instead of selecting the ends of those vertices of those two lines between the end points, I selected the actual lines. Now let's see if we get it does run, but let's see if we get the correct value, 4.58. And you do. So the answer to this is yes. And that takes care of the